Chapter 23 Line Graphs and Linear Graphs for Class 8. First we will see the line graph. So a line graph is a graph that uses point connected by a line to show how the data change a period of time. We will see some example to understand it better. So here I am showing an example of days and number of students present on that particular day. So Monday, Tuesday, Wednesday and so on, and look at the data. The number of present of student are the given. They are changed according to the time. So when we shows these data into a graph and by a line graph, so that's called the line graph. So we just have to point out these number of students according to the days, and then we join the point using the line that calls the line graph. I will show you how a line graph looks like. So for this example, a line graph look like this. So you can see here the Monday, Tuesday on x-axis and on y-axis all the students. So this is a line graph. Let's see some more example. So here I'm showing the second example, which is based on time and distance. There are some time given and a car, the distance of a car from the point A, it is given. Okay, and we have to show this data into the line graph. So according to this, the time and the distance we will take as x-axis on and a y-axis. So for this example, the line graph look like this. So by using this information, we plot all the points, and after that we will join all the points by the line. These are some example of line graph. Okay, let's take an example to understand it more better. So can you read this graph? Read this graph means, can you tell me what information is given in this graph? Think about it. Okay, we can say that this graph shows the sales made by a watch manufacturer every month, as sold watches shows in y-axis and months on x-axis. So we can see this example shows the various number of watches on different months, and these points shows the number of watches sold in a particular month, and all the points joined by a line of sold watches on a particular month. This is why this graph is called a line graph, and these are all the points. So when we join these points by a line, we can calculate how the data are fluctuate. As you can see, sales decrease in the month of March from January, and sales increase from month of March to May, and the least sold the watches are in the month March. Let's take an example of time and distance. So let's say this car has to travel 250 km from point A to point B. So we will make a line graph for this example. Let's say this car has covered 250 km on different time like this. Now we need a graph, and on this graph, on horizontal axis we will take the x-axis, and this x-axis shows the time which is given on the information, and on y-axis, the vertical axis, shows the distance covered by the car from point A. And for that we will need to take the scale of the given information. So one unit I am taking as 50 km. So this information will make used to mark the point. So on 12 p.m. the car has covered only 0 km. So we need to show the 12 km on x-axis first, and the intersecting point of 0, the time where will be the first point shown. Okay, now see that on 1 p.m. it has covered 50. So this is the 1 p.m. Let's take the intersecting line for the 50 km. So this will be the intersecting line for 1 p.m. at a 50 km, and we will mark the point here, and like this we will mark all the points, and after that we will join all the points by using the line. This shows us how the data fluctuate. So this is how a line graph drawn. So in the line graph we also can show two types of data as shown in this example. So here the number of motorcycles sold in a particular month are given. So the first line shows the data for the 2007 and the dotted line shows the data for the 2008. So these type of information can be used to compare the data. Let's take this example to understand it better. So for this example, let's take the first question. What information this data is asking for? So as shown by the month and on the y-axis the number of motorcycles sold, we can say there are two data as I already told. So the number of motorcycles sold in the different month of the year 2007 as shown, and the dotted line which shows the number of motorcycles sold in the various month of the 2008. So the number of motorcycles sold in the 2007 and 8, we will use this information to compare the data. Let's take the next question. How many more motorcycles were sold in March 2008 as compared to the March 2007? So we can see here 120 motorcycle has been sold in the March 2008 and 60 motorcycle has been sold in March 2007. So now compare 120 minus 60, which means 60 more motorcycle has been sold in the March month 2008. Similarly, let's take the next question for that. Find the month from both year in which the number of motorcycles are sold equally. So as both the lines are intersecting a point here, so which is this month? This month is the month April. So we can see here in both years the number of motorcycles sold in the month April is equal. So this is how we have to answer these type of questions. Now let's see what is a linear graph. So in simple, when we join all the point by the line and we found the line is a straight line, then the graph is called the linear graph. So now the method is same to plot all the points in the graph like this, but after joining the point, if we found the line is a straight line, then it should be called the linear graph, not line graph. Okay, so as in this graph this is a straight line, so this graph should be called the linear graph, not line graph. Now let's take the distance and times example to understand it more better. Now on the horizontal line we will take the x-axis and on the vertical we will take the y-axis. Now on x-axis we will show the time, which will show the 1 unit is equal to 5 minutes, and on the y-axis we have to show the distance, and 1 unit is equal to 0.5 kilometer. Accordingly we will point out it. Now for 5 minutes it shows a 0.5 kilometer, so we have to plot this point as it shows the 5 as x coordinate and 0.5 is y coordinate. Now this will be the intersecting line for this point, and now we will plot this point. You can name the point as well, but there is no need to name it. As in this example I am naming the point, all the points. Now all the points after intersecting or plotting in the graph, these points will be shown as like this. I am showing this point here in this graph like this. Now after pointing out all the point, we need to make or join all the point. So as you see, all the points are in a straight line. Okay, so this means this graph is a linear graph. We can't say any graph is a linear or any information is a linear or not. After making the graph we will get to know it. Now let's take one more example of linear graph. If a y coordinate is 3 times to the x coordinate, make the graph and draw a line graph, and is it a linear graph? Find it out. Okay, so as in the information is given, we will take y coordinate as y variable and x coordinate as x variable. So as y coordinate is 3 times to the x coordinate, so which means y is equal to 3x. Now we will make our data to ourselves. So if the x is 0, then y will be x multiplied by 0, 0. And now if the x is 1, then y will be 3 multiplied by 1 is equal to 3. Now if the x is 2, then the y will be 3 multiplied by 2 is equal to 6, and so on. So after making this all the data, we need to make the graph now. Now let's take the axis for this information. This is the x-axis and this is the y-axis. On the x-axis we will show the x variable, and on the y-axis we will show the y variables. Now for the scale x-axis, I am taking 1 unit as 1 scale, and for the y, 1 unit is equal to 3, and according to that we will make the scale. Okay, now we will find the location of the point according to the scale. Okay, so as the first information, x variable is 0 and y is also 0, which is lies here at 0. So we will point it out the intersecting line of x-axis and y-axis here. Okay, now similarly we have to plot x as 1 and y as 3. Okay, so x as 1 it is here in this, and y as 3 is here in this point. Okay, and similarly we will point it out all the points. You can name the point as well. Okay, now if the x is 2, then y is 6, which is here, and then you can name also. And when x is 3, then the y is 9, and at last see this. Now we have to connect all the point. So after connecting, it shows the line is a straight line, so which means this graph is a linear graph. So you only get to know the graph is a linear or not after plotting the point and join the line. Okay, now in the next example we have to find it out that given example is possible or not. There are 4, take the 1. So in the first example, distance is also increasing with the time after reading the graph. So is it possible? Think about it. Okay, so when the time increase, the distance might be increased, correct? You can see when a car travel with the time, the distance also increase. So which means the first information given is the correct information. So which means the first graph is possible. So now we can say that this is the correct graph. Now come to the second one. In this, time is increasing but the distance is same. Is it possible? The distance may be same. Think about it. Okay, as we have seen in the first example, the distance is increasing with the time, correct? But is it possible the distance is not increasing with the time? Yes, time is traveling, time is going, but maybe the car is hold at some point. So which means the second one is also possible. As in the third one, the distance is increasing with the time, decreasing with the time. So maybe the car is traveling back, okay, from the starting place with the time. So this means this graph is also be possible. Now at last graph is showing the distance is increasing but the time is same, time is constant. Is it possible? No, it can't be possible. The time can't be constant, time is always going on. So this graph is incorrect because the distance may be constant but the time can't. Okay, so this means this is incorrect, and this is all about the linear graph as well as the line graph. Thank you so much.